Hi guys, this is your video on finding areas of triangles in the Cartesian plane, and we will be using what we like to call the box-in method. So starting right from the top, if we're talking about area of a triangle, as you guys know, the traditional area formula is 1/2 base times height, where B is the base and H is the height, or as we now know, altitude of the triangle. So if we look at our first example, if I wanted the area of this triangle, it's pretty easy to compute because I can easily see that the base is 10 units because it's 6 here and then an additional 4. And then the height, which from the opposite vertex perpendicular, is 4. So I know area equals 1/2 base times height. So that's 40 times 1/2, which is 20. And I'll just label this as units squared, just so that we're being clear that we're talking about area here. Okay? But as soon as you come over to something like triangle number 2, if you wanted the height of this triangle, it's a little bit harder to compute because this base is diagonal. So what we're going to do instead is focus on finding areas of shapes that we know we can find to work towards the one that we need. So if you look at this, here is your box or rectangle that completely encapsulates that triangle. So I can find the area of that rectangle. If you focus on each of these triangles, those are right triangles, I can find the areas of those. So I can find the area of the rectangle and the area of each of those right triangles and subtract them away, and that'll leave me with the shape on the inside. So I'm going to label my work. What I like to do is label everything I'm finding the area of. So area of the rectangle. So this is 1, 2, 3, 4, 5, 6, 7, 8 boxes times 1, 2, 3, 4, 5, 6 boxes. 8 times 6 is 48. So 48 is the area of the rectangle. Now we're going to go triangle by triangle. So I'll just label this as 1, triangle 1. So this is 3 by 1, 2, 3, 4, 5. So area of a triangle is 1/2 base times height. So that's half of 15, which is 7.5. Then I move on to triangle 2. Okay, so this is 1, 2, 3 by, I believe this was 6. 1, 2, 3, 4, 5, 6. So the base is 3. I'll say the height is 6, and those are technically interchangeable. I don't know which one's the base or which one's the height. I just know they're meeting at 90 degrees because of that rectangle. So that's half of 18, which is 9. And then I'm moving on to my last triangle, triangle 3. So this is 1, 2, 3 boxes by, again, this bottom part was 8. So that's 1/2 times 3 times 8, so half of 24, which is 12. Okay, so again, in order to find the area of our triangle, the shaded area here, we're going to take the area of the rectangle, which was 48, and then I'm going to take away each of these individual triangles. Okay, so I'm just going to go ahead and grab my calculator. So I've got 48 minus 7.5 minus 9 and minus 12, and that's 19.5. And again, I'm just going to label that unit squared, so again, we're all clear that I'm talking about area here. We won't take off if you don't label it as unit squared. I'm just making a point. Now, the last one's a little bit more complex. What if I wanted to find the area of this polygon shape over here, which appears to be a trapezoid? I haven't proven it, but it kind of looks that way. Okay, so I want the area of this shaded region, which again, it's going to be very difficult to find the area of that using any sort of traditional figures or traditional formulas. So what we're going to do is box it in. As you guys can see, this is all completely boxed in. And then I'm going to find, and then I've broken it up into triangles I know I can find the area of. Now, after boxing this thing in, you can see this funny looking shape over here. Okay, now let me zoom in. That shape that I've just highlighted in pink is not anything that I can easily find the area of. So what we've done is we've just added in another line right here so that I can easily see two triangles where there's a height and there's a height, and then I can easily compute the areas. Okay, so I'm going to erase that because I felt like that looked a little confusing. All right, so we're going to start again. Find the area of our rectangle. Okay, so this looks like it's 1, 2, 3, 4, 5, 6, 7, 8. So 8, and then 1, 2, 3, 4, 5, 6. Okay, so it's actually the same box as what we did on the previous one. So this is 8 times 6, which is 48. And then just like before, I'm going to go triangle by triangle. Okay, so triangle 1, that has a base of 2, and we'll say a height of 1, 2, 3, 4. So this is 1/2 times 4 times 2. So that goes to 4. Of the second triangle, that's again going to be 4, but this time by 6. So 1/2. 4 by 6, which is half of 24, which is 12. Okay, triangle 3, which is over here, the height is 2. And the base is 4. So 1/2 times 4 times 2, which is 4. And then lastly, this one has a height of 1. So our final triangle is 1/2, 8 by 1, which is 4. So again, if we're calculating the area of our shaded region, this is 48, the area of the whole box, and then we're taking away each of those individual triangles to leave us with what's on the inside. So this is going to be 48 minus 4 minus 12 minus 4 minus 4. So I'll grab my calculator. So that's 48 minus 4 minus 12, and then I'm just going to write that as minus 8 because I know that combines to 8, and I get 24. Okay, so 24 is the area of our shaded region. Whoop. Okay, so those are our 3 warm-up problems there. As you can see, they gradually got a little bit harder. So if we come down to our first example, this one I'd like you to try yourself and just pause the video. Okay, so take a moment, pause, see if you can box in and calculate the area of this. If you need a hint at how to start the problem, you can see how I've boxed in my triangular figure because, again, I wasn't able to easily find the height here, so I boxed it in and I've identified 3 triangles, 3 right triangles in this case, that I can find the areas of to subtract away. So again, if you were stuck, there's your hint, and then you can hit pause and try again. All right, are you ready for the answer? It is 14. And here's all my work to justify it. So the area of the rectangle turned out to be 40, so 40 units squared. And then piece by piece, I was able to find that this triangle had an area of 8, this was 15, and this was 3. So I was able to subtract and get an area of 14 units squared for my shaded region. Okay, moving on to the next one. So again, a little bit of a weird looking shape that we want to find the area of. So I'm going to try to box this in. As you can see, I'm not going to be able to box in every single vertice. This is a lot like the third triangle I did with you guys at the top, where I get this funky looking shape off to the right. That's fine, because I can technically break it up into two triangles that look like that. Okay, so maybe we'll call this 1, 2, 3, and 4. And you should be able to find the area of that shape. So again, hit pause. We'll give you a head start and see if you can figure it out. All right, so the answer is 12. And here is my work. So I was able to find that the outside rectangle was 20 units squared, and then each of these individual triangles, as I have labeled, were 2, 2, 1.5, 2.5. I subtracted each from my whole rectangle, and I got 12. All right, last one, definitely the most challenging. This funky looking thing. Okay, so I want to find the area of this figure. So I'm going to go ahead again and try to box this thing in. So I'll pick a vertex here. Up, over, down, and back over. Okay, so as you see, I'm not going to be able to capture every vertex here. That's not the point. The point is I'm now going to break up this rectangle to, or break it up into shapes that I know I can take the area of and subtract away. Now this one's definitely more challenging because of some of the funky shapes that I've created. Like this is not technically a shape, and this is, well, not a shape that we can easily find the area of, and same for the other one. Okay, so the easiest one is this rectangle right over here. Or sorry, I said rectangle, this triangle over here. It's a right triangle, so that one's not going to need any breaking up. But what I can do, looking at this shape, is I could draw another line here, and that creates a right triangle there. Okay, now you may be thinking, okay, but then what about the thing on the right? Well, the thing on the right is actually a trapezoid. Now, if you're not comfortable finding the area of a trapezoid, fear not. I could draw another line here, and now it's a rectangle and a triangle. Okay, so let's actually do this. Let's call this 1, that 2, this will be 3, and then this one will be 4. And then I'll do the same thing down here. I could break this up by drawing another line there, because now that's another right triangle. And then again, this is technically a trapezoid, but if you're not comfortable with that, you could break it up into a rectangle and another triangle. So I've got 1, 2, 3, 4, let's call this 5, 6, and 7. Okay, so I'll give you a head start, see if you can figure that out. Go ahead and hit pause on your video. And there you have it. You should have gotten 12. I promise that's just a coincidence that it's the same area as the one above it. I actually even double checked. I'm like, wait, really? But yeah, so I've just discovered that this shape in here, by using the box-in method, is 12 square units. Okay, now in each of these scenarios, you guys have seen how I've broken it up. There's obviously other ways that you could have broken up these shapes into other rectangles or triangles that you see fit. And that's fine, just as long as you're showing your work and labeling appropriately so we can see how you're calculating the area. That's totally fine. It's open to interpretation on how you want to break up these figures. Like I had even said previously, technically if you wanted to, instead of doing two separate shapes here, that's a trapezoid that I've just highlighted right here. And that is calculated by doing the average of the bases. So 1 and 1, 2, 3. So 1 plus 3 divided by 2, then times the height of the trapezoid, which is 1, 2, 3. So that's 4 divided by 2, which is 2, times 3 is 6. So I bet if we put these together, which here they are, that's 6 units right there as well. So those are equivalent. So again, it's really up to you as long as you're showing your work. All right, and that was our last question of the video, so I hope you guys enjoyed it, and I hope this is a pretty easy topic. If you have any questions, obviously let us know. Thank you.